Howdy, friends. My name is Richard Lawrence. I am a user support specialist here at Texas A&M University, and I will be your instructor today. Our subject is containers. This course is the first of a sequence in which I cover topics of containers from different perspectives. So today's perspective is trying to understand at the low level how containers actually work. I'm going to make them feel hopefully less mysterious. So the current time is about 1:30. So we need to get started. Oh, that's so weird. My Zoom is bugged. It says there's 19 participants, but it only lists 3 of them. What are the odds? Okay. So today I'm going to talk about containers conceptually, and then I'm going to talk about 2 specific implementations, which are Charliecloud and Singularity. We will then log into the ACES cluster and do some container activities. The main container activity is building container images, which are a place where you store your software. And we'll do building images by hand, and then we'll learn how to write recipes so that we can build images repeatedly. In order to learn more about containers, we have a knowledge base, and I have populated the knowledge base with most of what I know about containers. So a lot of what we're covering today is on the knowledge base. Previous courses I've taught on these topics can be found on our YouTube channel. And of course, other universities offer their own learning resources. And I like the ACES CI links, which is a curated list of resources. But for today, the most important resource you need is this slideshow. And of course, the slides will be posted soon on the web page. If they're not already visible on the web page, that's okay. I do have the direct link to the slides, which I will drop in the chat. So the 2025 fall version of Fundamentals of Containers PDF is now posted in the Zoom chat. So I clicked the link and I now can see the PDF, which opens in your favorite PDF reader. My PDF reader is Google Chrome on this machine. And they can also be found on the web page if you navigate to the web page. And of course, you might have to force a refresh if you have cached an older version of the web page. But it doesn't matter how you navigate to the file. I do recommend keeping the file open in a tab so that if you want to copy and paste some code, you'll be able to do that. Now I'm going to talk about containers. And for this purpose, I assume that you, the participant, have never used containers before. Maybe you heard of them. They seem very mysterious. So I'm going to speak as though you don't know anything about containers and try to make them seem less mysterious. So the first question, what are containers? A container is a process that has its own view of local resources. So examples of local resources would include file system, user IDs, network. There are many others. Today we're focusing on the file system. A normal process, which I represent with a gear, would see the physical file system and it would view the entire physical file system as a resource. that it can read files from. But it's also possible for a small sector of a file system to itself be a representation of a file system, and that is called an image. The word image is derived from back when file system media were primarily optical. That's no longer the case, but the word is good enough. So an image is a sector of a file system, which is itself a file system. You can have a process which sees the image instead of the real file system. So as far as that process knows, the files in the image are all that exist in the world. You can probably guess what the advantage of this is. It's for isolation. If the container views the image as the file system, then it has really no way to interact with files outside of the image, so you get to choose which files it can and cannot see. Why do we use containers? Since this is a research university, I'm going to give you some science motivations. Containers are shareable. You can upload your container image to a repository. You can download container images that other people have uploaded. So when one person does work, we all benefit. Portability, because you can isolate containers from the software that is installed on the computer, they can be maximally portable. If you put everything the software needs in the image, then the only requirement is you have to use that image on a computer with the same CPU architecture. So the most common CPU architecture that we have is x86-64, which, for example, we have Intel CPUs with that architecture. AMD CPUs also can be made with that architecture. If you have an ARM machine, which are less common but can be found, for example, in a MacBook, then that would be a different architecture. So they would have a different image that would run on that machine. And so finally, reproducibility. If you build software and then you do science, you wish to be able to repeat your science, which means you need to be able to rebuild your software. And one thing that can happen is if you install software on a machine, but you are not the system administrator might change the software stack out from under you. And now your software doesn't work anymore, so you can't reproduce your science. But if you're working in a container and you put everything your software needs in the container image, then it doesn't really matter what the system administrators do to the software stack. The only requirement you have is that they won't change the architecture, which they usually cannot do anyways. So let's talk about what we put in the container images. So I would like to contrast the container with a similar technology called a virtual machine. Virtual machines and containers are both a way to isolate software from the host machine. But there are some differences. So on the left, I have a software stack that doesn't have isolation. So we call that the bare metal software stack. The hardware is at the bottom. The host operating system kernel, I assume we're all using some variant of Linux. Containers, if you're running containers on something else, then you'll need a virtual machine to translate between Linux and the actual host operating system. But if the host operating system is also a flavor of Linux, then they're the same. So then you have the host libraries. So those would be things like your compilers. You have the host binaries. So those would be things like your network tools, and the user application, which would be the code that you write. So the two different isolation technologies, virtual machine and container, both put as much as possible of the software stack into the image to make it portable. But there's one difference, which is that a virtual machine includes an operating system in the image, and the container does not. So the reason for this difference is that the operating system is very large in memory. In order to boot an operating system, you require probably like almost a gigabyte of memory just to do that. So if you don't need a new operating system kernel, if the existing operating system kernel is already good enough, then choosing not to duplicate that saves you a huge amount of memory. So containers can be much smaller in memory because they don't duplicate the operating system kernel. Instead, they use the host operating system kernel, and there is a translation layer between the guest libraries and the host kernel. So here are some popular container runtimes. Containers have actually been around for a while, but aside from some extreme Linux nerds, nobody knew about them. The first container runtime to break into mainstream was Docker. Docker is a container runtime that's primarily targeting researchers working on their personal machines. So you write software on your personal machine, you share with another researcher on their personal machine. And because there's a huge number of researchers who fit that description, Docker is instantly very popular. But Docker isn't perfect. It has problems. So for example, it was not designed to run on a shared high-performance computing cluster. So in order to address some of its deficiencies, some new container runtimes emerged. The first on my list is Singularity. Then we also have Shifter and Charliecloud, which came a little later. And these three all solve the same problem, which is how do we do what Docker does, but on a shared HPC system instead of on your personal desktop? And they all have kind of similar strategies. The main idea is they take security very seriously. You can't be allowed to harm the other users on a shared system. This last one on my list is I'm mentioning here because it's also popular, but it solves a different problem. Podman here was also designed to address security, but not for shared clusters. It was designed to address security in the cloud. So we won't be seeing much of it on our shared HPC cluster, but it is a very relevant technology outside of the HPC world. And from among the three HPC technologies, Singularity and Charliecloud are both in use on the ACES cluster, but not Shifter. Shifter was primarily designed for Cray clusters. We don't have any Cray machines on ACES, so we don't have Shifter. I will now discuss the two that we have in more detail. The first I will discuss is Charliecloud. Charliecloud is a lightweight, fully unprivileged container solution. It was developed by Los Alamos National Laboratory and is completely open source. So, for example, I have contributed one commit to the Charliecloud repository. The logo is a tugboat and I don't know why. So what do we need to know about Charliecloud? So here are some of its features. Charliecloud is both a container runtime and an image builder. That's important because if you're working with containers, you might need to be able to build new images with different software. So Charliecloud allows you to both run your software and build your software so you can do all of your tasks. Charliecloud can read and convert Docker images. That's important because the majority of images out there in the wild are Docker images because Docker came first and is still the most popular. The file system inside the container is isolated. That is probably the core feature of any container runtime. The user inside the container is isolated. So this is a feature that means that if your username is something like Richard on the shared cluster, that's my name, but inside the container process, my process has its own view of the username. So I could decide my username is root inside the container. And as far as the process knows, I am the root user. But when that gets translated from the container to the kernel sees my real actual username. So I don't gain any extra privileges outside the container. And that concept will be important later. Finally, Charliecloud works with high-performance cluster technologies because it has the strategy of being very transparent, so that if you need to do any work with the hardware, it will allow you to get to the hardware. It doesn't stand in your way. So we can read more about the Charliecloud manual, as far as I know, is being served from GitHub, but the source code has been migrated to GitLab. So this might end up at GitLab someday. Charliecloud, well, when I created this tutorial, there's a good question. Robert is asking, are we saying Charliecloud isn't OCI compatible? When I created this tutorial, the OCI compatibility was not complete. So the strategy we're using today is full conversion from one format to another. However, it is at least planned for Charliecloud to be OCI compatible, but I do not know what the current status of that is. I haven't updated my tutorial. So it's possible that the most cutting edge versions of Charliecloud are OCI compatible, and I didn't bother to check. So if you like OCI, that you can continue to use it, but for this tutorial, I'm just doing the technique that worked for me in the past. For people who may be confused, so every container runtime has its own specific file format, but also there's a universal file format called OCI, and many of the runtimes have begun to adopt OCI in various stages of developing that feature. So in the future, all images will be compatible with all runtimes, but for now, we have to practice converting from one format to another. So let's talk about Charliecloud on ACES. Charliecloud is available from our module system. Our module system is based on lmod. So you use the module load command. Module load Charliecloud gets you the most recent version of Charliecloud that was installed. Charliecloud images can be large on disk, so we need to be aware of your storage quota. On the ACES, you have a file storage quota, and the two storage locations that are available to you, Scratch and Home, Scratch has a larger quota, so we're going to be putting the images there. Next is some container activities may be too CPU intense for the shared login node. We do have limits on the login node, so you need to be courteous to others and use a compute node when you're doing the large image operations. And I will teach you how to do that when it becomes relevant. Finally, some container activities may be too I/O intense for the shared network file system. On ACES, we have a Lustre file system, and Lustre does not do well when you have to do many thousands of small file operations. And so when that will be relevant, we will target a local file system to that compute node rather than the shared network file system, and I will teach you how to do that when it becomes relevant. Next, we'll talk about Singularity. So Singularity is an easy-to-use, high-performance container solution presented by Scilabs. Their motto has changed. I don't know if this is their current motto. That's what it was like a year ago when I checked. Scilabs is a for-profit corporation, but they follow the new model of profit, which is instead of selling software source, they sell software services and the source is available. That's probably one of the coolest things about this century is the source code is no longer the only way to monetize products. So Scilabs offers source code for free. And because of that, I have to tell you a small story. The moral of the story is Singularity is Apptainer. Scilabs, a for-profit corporation, created a product named Singularity. But of course, when you're a for-profit corporation, you can't just have one version of a product. You have to have the community version, the enterprise, the pro, and the extra services so that when your high-rolling customers come along and want to give you more money, of course, there's a way for you to accept the money. If you were listening, of course, the Linux Foundation was listening and they said, oh, did somebody say free? Don't mind if I do. So Apptainer is the Linux Foundation's fork of the community edition of Scilabs. They contain essentially the same code, but the Linux Foundation has taken off the Scilabs branding. So it's like, completely generic. And so really the only difference is, do you want to do business with Scilabs or not? If you want to do business with Scilabs, then you would use Singularity branded software. If you don't want to do business with Scilabs, then you use Apptainer, which is the generic unbranded version of the software, but they have the same code under the hood. So there's not really a difference, and I will use the words interchangeably. So let's talk about some features of Singularity. Singularity is a container runtime and an image builder. That's important because you want to be able to do all your tasks. Singularity can read and convert Docker images for the same reason. That's because the majority of images in the wild are Docker images. In the future, OCI will hopefully be more popular, but right now we're dealing with the situation that we're currently living in. And the file system inside the container is isolated. That's the minimum feature for any container. And here's a difference from Charliecloud. Singularity does not give you user isolation. Instead, your user inside the container is the same as the user outside the container. So that means that if you're using Singularity, you don't have to worry about who is who in the container. You are always yourself. So that's the maximum simple solution. Is it better? It's not better or worse, it's just a difference. Singularity works with high-performance cluster technologies, but for a different reason. Instead of getting out of the way and letting you do it for yourself, Singularity has done it for you. Scilabs has put in a lot of work to make sure that their technology intuitively understands how to get all these hardwares working. So in general, when Singularity it can use hardware, it does so more easily because it's been pre-programmed how to do that. Is it better or worse? It's just a difference. So I would recommend to you to read the Apptainer manual. It has the same information, but without the Scilabs branding. Let's talk about Singularity on the ACES cluster. Singularity is available on the compute nodes. It's not available on login nodes. Historically, Singularity activities are too CPU intense for login nodes. The other difference is Singularity is not part of the module system. It is installed on the bare metal on every compute node. So you don't have to do module load. It's just there. The next facts are pretty much the same as before. Images can be large on disk, so you need to be aware of your storage quota. Container activities can be too intense for the shared network file system. So we'll use a local file system when that's relevant. It's almost time to get started. Who is excited to log into the ACES cluster and do some activities? So here's my slide, which is the overview of how to get onto the ACES cluster. When you signed up for this short course, we would have created your login on the ACES cluster, and the way to try that out is to navigate to the ACES portal. So if you've been to our homepage, then there's a portal menu, and the ACES portal is one of the menu items. Also, I can just drop the link into the Zoom chat. So there's the link to the ACES portal. The ACES portal is a web interface powered by Open On Demand. Open On Demand is essentially the universal technology for access resource providers to present web interfaces to the national community. Please do take a moment to try to log in. When you try to log in, it will redirect you to Access CI Logon, and you can choose your identity provider. You may use the Access CI normal password strategy, which is what I'm showing on this slide. But I personally prefer to provide my home institution as the identity provider. So I select my home institution from the dropdown. Then instead of the access password, it takes me to my home institution's login page, and I can go from there. Which login page you land on depends on how you configured your access ID. In almost all cases, there will be two-factor authentication. So I have Duo on my phone, and it goes bling, and then I have to push some buttons. When you do get to ACES, we'll be using the shell, but I'm not going to click on that just yet. First, I want to make sure everyone is able to log in. So I'm going to shrink my slideshow, and I'm going to open that link. The ACES portal. So I have configured my access ID so that I can log in using my Texas A&M University institution identity provider. So I click log on. And since I have recently logged in to my Texas A&M, probably, yes, it just skips straight past. It reuses the same browser token. So I logged into my browser using my tamu.edu account. So essentially, the TAMU login page recognizes that, says, okay, you're good to go, forwards the credentials to Access, forwards the credentials to the ACES portal, and I don't have to click buttons all day long. So that's a cool feature. So the ACES homepage has the message of the day, which never changes. So I don't even know why it's called message of the day. It's the message of the year, apparently. And there are a lot of menu items at the top. So the files menu we'll be using to put together our software at a later time. The jobs menu, you can take a look at running jobs. We don't have any running jobs at the moment. The clusters menu is how you get to a login node, if you will be getting to a login node. Interactive apps is one way you can start the fancy softwares. We won't be starting any fancy softwares today. If you haven't joined the affinity groups yet, here's a convenient place where we have stored the links. We have a chat bot where you can ask a large language model fun facts about HPRC. It essentially scrapes our knowledge base and tells you what it found there. The dashboard will tell you about your file quota if it's a problem, and I think there's supposed to be some more menus, but they've been cut off. How are we doing on logging in? Has everyone been able to reach the portal homepage yet? Okay, so one person is giving the thumbs up. I think my Zoom is bugged because it still only shows 2 participants, even though there's definitely more than 2 people here today. I'm going to have to ask my colleague to help me keep an eye on the participants. I don't recall when I updated my Zoom, but it could be time for me to update my Zoom. But I think it's because I have SE Linux, which is the Red Hat security system, and I never bothered to teach Zoom how to play well with SE Linux. So sometimes it tries to look at a file it's not supposed to look at, and SE Linux is like, don't do that. It still runs, but I get the pop-ups. Okay, so we do have our first error in the Zoom chat. That's a common error that we've seen. Usually it means that we didn't quite finish setting up your login yet, so we need to examine that. Normally, I would help examine the logins, but I'm sharing my screen already, so I'm not sure if I'm going to be able to do that personally. Yeah, so because we've just recently added you to the training allocation, your user login may not be fully set up on the portal yet. James Kennan has posted a different error. I'm less familiar with that error. That feels like your access ID is broken. Perhaps you put in the wrong username or the wrong identity provider. Hey, excellent news. We're having some more success in logging into the portal. So I think that I'm comfortable to proceed with the instruction. In order to try some container activities, we're going to get onto a login node first. And we're going to be operating on the command line for our first activity. So when I click the button, when I click the menu item, it opens up a new tab. And this tab is a basic looking shell terminal with a message of the day and some facts about my files. I have many files, but that's not important right now. So I'm going to clear my screen. Let's check which login node I landed on. I landed on login 2. Would anyone like to share in the Zoom which login node you landed on? ACES has 3 login nodes, and you should get one of them at random. Sometimes certain login nodes will be less cooperative. So if we identify an uncooperative login node, we'll just try again to get onto a login node and hopefully get a different one. Welcome to the ACES login node. So we're going to do a Charliecloud activity first. And in my slideshow, I have instructions, which if it's green highlighted and the courier font, that means I would like for you to follow along and execute the commands with me. So if you have your PDF open, you can copy and paste from your PDF, but these ones are small enough that it's probably better to type them by hand. Module load Charliecloud, and we have tab autocomplete, a very wonderful feature. Module load Charliecloud, module list Charliecloud version 0.33. I know there are newer versions of Charliecloud available, but for the purpose of this tutorial, you don't need a particularly new version of Charliecloud because the fundamental concepts will be the same. I see that there's a question in Zoom, but I'm not able to answer that question, so I'm going to defer to my colleague. So now that we have Charliecloud software, let's try a Charliecloud executable. So the first Charliecloud executable we're going to try is chimage. Chimage is a tool that can help you build and organize container images. It can also fetch them from repositories. So if you wanted to know what it can do, you would use its help argument. For the moment, we're going to be using its ability to fetch images from repositories. So that means it has a command word, chimage, and then a command word. Pull is the command word for fetch a container image from a repository. And then the argument for that command is the name of the image you would like to fetch. Images are usually named similar to how we name a Git repository. So it will have a word and then a colon followed by a version. since we didn't specify a location for the repository, such as a URL, Charliecloud is going to assume that we wanted the default repository, which is, of course, Docker Hub, because Docker Hub is the most popular container repository. And what is Alma Linux? Alma Linux is a small distribution of Linux that's purpose-built for putting inside of containers. So the material point being that it will not take very long to execute this command. So there's some debug output that says it's doing work, and a few seconds later, it is done. So how do we know what we have just accomplished? Well, we can ask Charliecloud what images are available. So we can use the chimage list command. And it says, I have an image, and its name is Alma Linux 8. I would like to also discover where on disk that image has been saved. But first, a question from Zoom. Can I pull any image from Docker Hub, or must it be converted first? Because Charliecloud knows that Docker Hub stores images in Docker format, you do not have to specify that you want to convert, because it's going to do that at the same time. If you're pulling from an arbitrary repository that may be in one of several formats, then you would have to specify the source image format and the destination image format. Chimage, the destination image format, is going to be, we'll talk about that later, but for now it's the default destination format. Converting is often implied. And that's a common theme among container runtimes. But you will occasionally manually specify the conversion, and we will practice with that later today. So back to this Alma Linux. We've just fetched it. So now it's on the login node. But what is it? Is it a file? Let's investigate. Charliecloud stores images in a local repository, which has a path that is saved in this environment variable. So let's inspect the environment variable. It's a path. Starts with /tmp. So /tmp is a local disk for this specific node. So every node has its own /tmp. And here I have my username followed by .ch. So Charliecloud has created a directory, which is my local image repository on this node. And what is there? So if we hit that directory with ls command, we can see that it has some directories that Charliecloud uses to do its work. And it also has an image directory, which is where the images are stored. So this image is stored here, and it is, in fact, stored in the form of a directory. The LSL flag shows the letter D. So Alma Linux image is actually a directory. So are there any questions about Charliecloud fetching an image from the internet and placing it into a directory on the compute node, on the login node? There will be questions, but we'll have to talk more about those later. We need to keep moving because right now it's hands-on time. So let's talk about Linux. So the ACES login node is a Red Hat Enterprise Linux. How do we verify? We would just read the Red Hat release file. So if we read the etc. Red Hat release file, we can see that this login node is running Red Hat Enterprise Linux release 8.10. But we've just fetched Alma Linux. So we should be able to compare. Let's start a container. So that means we need a new executable. The chrun executable is used for starting containers. Remember, a container is a process that has its own view of resources. So we want to start a bash interpreter process, and we want it to view the ALMA Linux image instead of the physical file system. So the syntax will be chrun, the name of the image, then the name of the process. So that's chrun ALMA Linux 8 bash. That will start a bash interpreter process that we can use to play around with. Chrun ALMA Linux 8 bash. And now I have, my shell has changed. The prompt now no longer contains our nice cluster-specific configuration. Now it's a generic bash interpreter. And the generic bash interpreter has generic bash tools like cat and ls. So let's use them. If we cat the etc Red Hat release file, we can see that this bash interpreter does not find the file that's on the real physical file system. It finds a file that's in the image instead. And that file contains different content. The content is ALMA Linux release 8.10 Cerulean Leopard. How do they come up with these names? I don't know. So now we have this bash interpreter which sees the files in the image. And when you're done with your process, you just shut it down using the normal way you would end any process. So for a bash process, that's the exit command to shut down this process. And now we have returned to the regular login shell process. Any questions so far about this activity? Why don't we do the exercise again, but this time we'll use Singularity. So Singularity is not available on login nodes. So the first thing we need to do is get to a compute node. There's more than one way to get to a compute node, but I have here the command line syntax that will get you to a compute node. So if you just starting from the login node where we already are, we can get to a compute node by executing this command line syntax. And since we do have a reservation, why don't we use the reservation? So I'm just going to add the reservation flag, which of course has to be, with the other flags. So before the word bash. So I want to start a bash interpreter, but I want it to be on a compute node. That's all this syntax does. It said, no. Did I make a mistake? Apparently, I made a mistake. We need the n tasks. How about 1? Okay. Job submitted with no account set. Then we get the default account. Okay, so my tutorial is out of date because our Slurm configuration has been updated. So the flag for n tasks is now required. So I will drop that flag into the Zoom chat. So you don't have to type it by hand. So that's the syntax I used. If you're copying and pasting from Zoom chat, watch the new line characters. This was meant to be all in one line. So now I am on a compute node. How can we tell? I am on AC005, a compute node that was reserved for this training session. And what is running on this compute node? If we cat the Red Hat release file, we can see that it is also running Red Hat Enterprise Linux release 8.10. Now, before we use Singularity, we have to set up some variables. For Charliecloud, we did module load Charliecloud. For Singularity, we don't need to load Singularity, but we do need to set a directory for the destination because Singularity needs to drop the destination somewhere. And I recommend that we tell Singularity to put the image in a temporary directory. Not just any temporary directory, Slurm's temporary directory. So Slurm, the advantage is Slurm automatically cleans up its temporary directory after the job. So if we do it like this, we don't have to worry about cleaning up after ourselves. Let's investigate that directory. So it too is located on a temp partition, which is a local file system for this node. But this time, it's not named after my username. It's named after a job. And that's because Slurm created this directory, and it will delete the contents after the job ends. Evan says, invalid account or partition combination specified. A question in Zoom chat. What does the memory allocation mean here in srun? So Slurm can be configured so that your job specifies what hardware resources will be allocated to that job. And on ACES, we do require that you specify an amount of memory that's like RAM memory that will be allocated to your job. If you start a process that consumes more memory than you have been allocated, then the job will abort because essentially you're not allowed to use more memory than you have been granted access. So we just need to pick some amount of memory. We're not doing anything that's particularly memory intense at the moment, so almost any number will do. There's like many hundreds of gigabytes of RAM on the compute node, and we just need a tiny fraction of it. Right, so I need to set my environment variable. And we talked about that environment variable already, and then we need to set one more environment variable, which is the web proxy. The web proxy is because the compute nodes are not connected to the internet by default. So in order to reach the internet, we have to set an environment variable that says you can get to the internet by using a proxy server. So there's an environment variable, echo HTTP.
Hey, Richard.
That's what it does. Yeah?
Some of us, I think your screen share froze. Can you unshare it and share again?
Oh no. How long has it been like that?
I see it now.
It was when you were trying to troubleshoot earlier.
Oh dear. Okay. So, anyways, this is what my screen is supposed to look like. I've executed srun, and I've executed the two commands that were on this page. So this is the first slide of the Singularity instructions. I haven't gone beyond the first slide yet. So this is all I've done. srun, and then check the Red Hat release, and then set these two environment variables. And I would like to know if people are caught up, or if they need time to catch up to this. And Henry, are you still not able to get past the account error? Henry, if you execute my project one word, does it show you any account numbers?
Also, yeah, I still having the same issue that it says that it's kind of like a problem with the account that is not set or something. So can you share the command that you tell me? Should I run in the terminal for checking? Thank you.
Yeah, chat. So you need to execute my project, and there should be an account number there. So for example, I have multiple allocations, but the one that we're supposed to be using today is the training allocation, which I believe to be this one. So if that's not your default, you can make it your default by using my project D for set your default, and then that number. That's how I did that. And then I need to check on the reservation. So we have a training reservation, and the group includes this group. And I am, of course, a member of that group. Is that the right group? I can never remember which group is the right group. This seems to be the correct allocation. It has the correct expiration date. So I don't think this is an allocation thing. At least it's not an allocation thing for me, which is not helpful because it's working for me. So let's suppose that we wanted to add the account on the command line. We would have to add the account that's capital A for account on the command line. So if this is our training account, invalid account or account partition combination specified. I wonder if you are in the correct groups. Yes, you're in the correct group. Right. I am very confused. Is anybody actually able to use srun to this training reservation? Or is it only working for me? It's working for some people. It works for some people and not others. It's a mystery. We're gonna need some help, I think. Let me get on my internal communications. I apologize for the inconvenience. This is meant to only be a quick exercise. I would like to finish the quick exercise. We won't be needing Slurm again for some time today, so we'll return to trying to make Slurm behave itself later. For now, I just need to finish the exercise. So previously, with Charliecloud, I showcased the two-step workflow, pull and then run. Singularity has a one-step workflow. So this time I'm going to showcase that. The Singularity shell command can do both tasks. It can pull and launch a process. The syntax for shell is a little different because the shell command already includes the idea that it's going to launch a bash interpreter. That's already included. Or whatever your favorite interpreter is. So that isn't needed. So the only argument that's needed is actually the location where the image is. But instead of an image in the local repository, this is the image on the internet. Unlike Charliecloud, Singularity does not assume that it knows that the remote repository is going to be in the Docker file format. So you need to specify, I wish to fetch from a Docker repository. And then you provide the path to a Docker repository. In this case, there's no path to the repository. It's // there's no path. So it is the default path. The default path is Docker Hub. It's the same default. It's a mystery to me why Singularity has a default repository, but not a default file format for the default repository. Anyway, that's the way it is. So it's Singularity shell, file format, no path because it is the default repository, and then the name of the image. It's the same image we pulled before. Alma Linux 8. So we'll do the exercise. So we need Singularity shell. That's the exercise we're doing. Docker / Alma Linux 8. And there's some debug output. Singularity does sometimes take a little longer than Charliecloud. I do not know the reason. So Singularity is ready. My prompt has changed. Now, instead of a configured prompt that matches our cluster, we now have a generic prompt. But Singularity has configured it. It's just a little bit of added prettiness. But it is, in fact, a shell terminal. So we can do shell commands. We'll do cat, etc. Red Hat release and confirm that we are now viewing the image as the file system. And then we exit when we're done. And then now that we are I am done with the compute node. So I'm going to shut down my bash process on the compute node. Now I'm back to my bash process on the login node. So has anybody in the been able to complete this exercise? Please throw the reaction in Zoom if you have been able to complete this exercise. I'm glad to see that Slurm is working for some people now. I don't know what changed. It's a mystery. But now that we can complete the exercise, I'll give you a minute to complete the exercise. Go ahead and throw your reaction up in Zoom when you've completed the exercise. So network is unreachable means you probably forgot the module load web proxy. Remember, compute nodes are not connected to the internet by default. You need to set a variable. And that's what module load web proxy is for. So on the previous slide, you need to set two variables. You need to set a cache dir. Otherwise, who knows where Singularity is going to put the image? Nowhere good, probably. And we need to set web proxy so Singularity can find the internet. Okay, so that will conclude this activity. And that means I get to congratulate you on successfully completing your first container activity. Congratulations. Welcome to the wonderful world of containers. Fireworks. It's very exciting. It's not magic. It's just files. And we're going to see more files as we go on. But first, I feel like people need a break. We've been struggling with Slurm. That's not fun. So let's take a break. And we'll come back in about 10 minutes and learn some more concepts of containers. Howdy, friends. Welcome back from your break. At this time, we will now learn some more concepts of containers. We're going to start with images. Previously, we fetched a pre-built image from the default remote repository. Now we need to learn other things we can do with images. So Charliecloud has two main image formats. The first is called directory, and the second is a single file, and there's more than one kind, and we support the Squashfs file system format for single file images. We'll be discussing the directory format first and the single file format later. The chconvert tool copies images from one format to another. So sometimes the chimage tool implicitly converts. When you need to just convert and not doing any other actions, we have the chconvert tool. So when we're working with images in a directory format, the image name will end in a slash, and that is the hint, kind of like how files have extensions. So that is the hint that the format of the image is a directory. If you don't have an extension, then Charliecloud will have to guess what the format is, and I don't know what it will guess. But if you put the slash, then it knows, oh, you definitely mean directory. So the main property of directory images is that they are writable. You can add, modify, delete files in the image file system. The other property of directory images is that reading and writing from them can be very slow. So slow, not say relative to a network file system. The point is that they're doing thousands of small file operations on an image is very difficult for a network file system to keep up. So you will slow down. And therefore, we put directory images on a high-speed local file system such as temp to mitigate that drawback. Here's another fun fact. We previously investigated the CH image storage directory where Charliecloud keeps your local copy of an image, and we observed that the image there is also in the directory format. But when you refer to images that are in Charliecloud's repository, you do not use a trailing slash. When the image name doesn't have a trailing slash or an extension, it means this is a special image that's in Charliecloud's local repository. So let's have an exercise. We'll create a space on the login node that's on the high-speed temp file system. And you're allowed to do that. So you can just name it after yourself. That would guarantee that you're not using the same directory as anyone else. So $user is just short for your username. Oh, it looks like my shell expired. I'll have to get a new one. Okay, so I don't yet have a temp directory for myself, so I will make one. mkdir temp user. Now I have a place to put an image. So I would like to convert Alma Linux from the cache to a directory format that I can then play with. But of course, chconvert is a Charliecloud executable, so I need Charliecloud software. And since I restarted my login, I don't have my variables. So I have to execute module load Charliecloud again. Now I can do chimage list, and Alma Linux is still here. Excellent. And now I can do chconvert Alma Linux 8. Oops. Alma Linux 8. So when I don't have a slash, that means this is the one that's in the cache. And then I want to have the destination be in temp user, ends with a slash, temp user, and then I can give it any name you want. What did I name it? I named it Alma Linux in the example. It's going to create this directory. So the directory ends in a slash, so that's the hint that we're going to create an image in the directory format. And it only takes a moment because temp is a high-speed local file system. So now we can investigate that directory and see what's there. The contents of the directory is, well, it looks like the root of a Linux file system. Not dissimilar to the root of the real physical Linux file system, except it doesn't have our ACES specific extra directories like Scratch. So there's no Scratch inside the Alma Linux, for example. So what can we do? I would like for everyone to confirm with the thumbs up that you've been able to do this. You probably needed to execute module load Charliecloud and mkdir and chconvert. If you landed on the same login node as before, you already have Alma Linux 8. If you landed on a different login node, you would have to execute chimage pull again to get a copy of that image again. Everybody remember how to do that? Or is anybody not able to do this? Did you run into an error? It is on the login node, so at least Slurm's not going to be bothering us right now. Okay. Thank you, Holly, and that means we're ready to proceed. So now that we have a directory format image, let's see what we can do with it. Well, we know that the main property of the directory format is that it's writable. So let's write to it. The way that you're supposed to write to images is you're supposed to launch a process that sees the image and then modifies it from within that process. You're not supposed to modify images from outside the container just by using file tools, because the permissions might be wrong. Container images are very sensitive to whether the permissions are correct. If you create a random file and the permissions are not correct, it could break the whole image. So you have to let your runtime create files and set permissions. And the easiest way to do that is to create files from within a running container process. So the runtime is always involved. So how do I do it? Chrun, we previously did chrun image bash. This time we're going to add another option, the write option. And it's the path to the image. I use tab autocomplete, which expands the variable because it's one of the bash built-in variables. So it knows how to expand it. And then I need to, okay, so it's chrun write, name of image, name of process. And now I should be able to do bash commands that modify the file system. So an example would be creating a directory. mkdir / spicy directory. I just made it up. And then we need to verify that even if we shut down this process and start a new process, and we don't need the new process to be writable, the new process should be able to find, yep, there it is. Spicy directory is there. So what I have demonstrated, what you should learn by experimenting, is that you too can persistently add files and directories to your container images if that container image is writable. And while you're finishing that, I will talk about the next file format, the Squashfs image format. A Squashfs is an open source file format that is used for file system images. I mean, well, you can compress anything. It's just a compressed archive, but it has features that are really useful for when you're compressing an entire file system worth of files. The whole file system becomes one single file, and that file maintains a index into itself so that you can efficiently retrieve its contents. And despite the fact that it is a compressed archive. So the image name has an extension .sqfs. That's the extension for Squashfs images. If you use the extension, then that is the hint to Charliecloud to what format you want the image to be in. If you don't specify the extension, then Charliecloud will not know what format you want it to be in. Squashfs images, so the main property of them is that they're read-only. Once you have compressed the files, they cannot be modified in a compressed form. You have to rebuild the entire image and recompress it. So modifying it is not an option. If you wish to change it, you have to first convert it to a writable format, write to it, and then convert it back to the Squashfs format. Squashfs read operations are fast because the files maintain an index into their contents. So once you are reading from a Squashfs image, you do not need to keep hammering the network file system server node with metadata requests to find files and their properties. The files and their properties are already stored conveniently in an index. So your local machine can do all of that file system logic on its own, and it only needs to query the server to get the actual contents of files. And the Lustre file system is very efficient for delivering the contents of files. So it's perfectly fine to put your Squashfs images on the Scratch file system on ACES. So let's create an area in Scratch, navigate to Scratch, create a directory for yourself, and we'll put a Squashfs image there. So if I go to Scratch and I name mine C_tutorial, that's Charliecloud tutorial, or container tutorial. You can name it whatever you want. Container tutorial. It's just a plain directory where we're going to put some files. And I can confirm that I have created a directory on the Scratch file system. Now, when we execute chconvert, we can convert from the directory format image that we own on the temp drive to a Squashfs image. And if you don't specify a prefix, that means in the current directory, which is just the normal bash convention. So chconvert from the, whoops, I need $sign if I'm going to write it like that, from the directory format image in temp to, and you can name it what you want. I'm going to name it, whoopsies, I somehow messed up my terminal. I will try again. Chconvert temp user Almalinux. Almalinux. What happened? Somebody's messing with me. Oh my goodness. For some reason, that was really hard for me to type. I should have just pasted it. Okay, so this is a fast operation because it is a very small image. If this was a large image, this would be a very slow operation. So I can investigate. I see that I have almalinux.sqfs, and it is 16 megabytes. It's not very large. So what can we do with almalinux.sqfs? Well, it's an image, so we can use it with chrun to start a process. Chrun almalinux.sqfs bash. And we can see that the spicy directory is still present. Remember, I created spicy directory way back when this was a directory format image, and after changing its format, spicy directory is still here. But now spicy directory is read only because it's inside a compressed archive. So if I tried to modify spicy directory, it would say, no, you can't do that. I'll show you. rmdir spicy directory. No, it's a read-only file system. It doesn't even say permission denied. It says read-only file system. Like, it's not even possible. Not even if you had sudo root everything, still can't do it. Okay, and I'm done with that process, so I close it. Are there any questions so far about working with the compressed archive in the Scratch directory with the persistent changes? We can essentially do the same exercises with Singularity. Singularity also has two main formats. There's a directory format and a single file format. They're not exactly the same. Singularity uses a format called SIF, Singularity Image Format, for single file images. It's very similar to the Squashfs, but it's got this Scilab's, extra stuff. The point is, it's a compressed archive that's fast to read over the network file system, and it's read-only. It has basically the same properties. So when you're working with Singularity, Singularity does not have a convert executable. It has a build command. So Singularity build, which it has a lot of things it can do, and one of the things it can do is convert from one format to another. Unlike with Charliecloud, with Singularity, there is a different way to specify the format of the directory image if it is the output. And that is, you use the sandbox flag. The sandbox flag is your hint to Singularity that the output is in a directory format. The trailing slash is not relevant to Singularity. Okay, so to do a Singularity exercise, we need to get on a compute node. As I recall, we needed a few extra options. So I'm going to scroll up in my Zoom and grab my srun command that had my extra option that I needed. Paste that in the Zoom chat. Paste it in my terminal and get on a compute node. Last time I landed on AC5. I wonder where I will land this time. Also AC5. I'm back on the same node. What are the odds? Now I need to set my variables again. Singularity cache dir equals tempter, module load, web proxy, and make sure we're still in your Scratch directory. Okay, yeah, I'm still here. I didn't drop off, so I don't have to CD again. Anybody having difficulty getting back to your compute node this time? I do recommend copying and pasting out of the PDF, except for apparently we need ntasks1, which is not in the PDF. So for that, I have dropped it in Zoom. Okay, so in order to convert an image, first we need an image. Previously, we showcased converting from directory to SIF. Sorry, I previously showcased converting from directory to single file. This time, let's showcase converting from single file to a directory. We just try it both ways. So the Singularity pull command can implicitly convert formats while it's fetching. So it's going to convert from Docker to SIF in this example. So we're going to have a Docker, the remote repository is in the Docker format. The local saved image file will be SIF, single file image. And then as a second step, we'll convert again from SIF to directory format. But notice that the order of the arguments is not the same. Singularity poll is destination then source. Charliecloud was source then destination. I do not know why they're different. Just be careful with that. Singularity poll almalinux.sif, the extension matters, docker://almalinux8. Typing is hard. I think my fingers are cold. It's a bit cold in my office. This is probably why I keep on making typos. Last time this took about 30 seconds. I'm expecting it will take about 30 seconds. All right. So that's ready. Now I have an image. I will inspect it. So now I have two single file images. One is the Charliecloud format. The other is the Singularity format. I wish to convert my Singularity format from single file to directory. So Singularity build -- sandbox. And the destination will be in the slurm temporary directory so that it gets cleaned up after the job automatically. And I can name it whatever I want, almalinux, for example. And then the source will be the SIF that's here in the current directory. All that right? There's going to be a little bit of debug output. It's pretty fast because it's a pretty small image. And now we should be able to inspect that directory and see what kind of, yep, those are the same files we're used to. Oh, not exactly. So you'll see there is one new thing. Singularity actually inserted a little bit of its own configuration while it was converting from Docker to SIF. And when we convert from SIF to Sandbox, that configuration is still there. So Singularity has inserted a little bit of its own configuration into the image, which is persisting even though we're not in that file format. Now we're in the directory file format. So we can repeat our writing exercise. The argument is slightly different. Instead of write, it is now writable. Otherwise, a very similar syntax. Singularity shall writable path to image, make some changes, and then see if they're still there. Singularity shall writable temp dir / almalinux. Let's see what there is. I'm going to create a file. Touch something.txt. Oh, well, I want it to be at the root. /something.txt. Yep, there it is. And then if we exit and start a new process, and it doesn't have to be writable, something.txt is still there. So the persisting is working. Any questions about doing conversion of file formats and writing to images with Singularity? Here's a fun question. We've just seen two different directory format images that were both almalinux. Are they, in fact, different? Or are they the same? Here's a fun experiment. now that I'm still on my compute node, I can do module load Charliecloud on the compute node and try to run that image. Chrun tempter bash. Oops, I forgot. That's not what's called. It's tempter alma Linux bash. And you can see that it works correctly. Charliecloud can launch a bash process targeting the image Singularity made, and the persistent changes are still there, both Singularity's configuration and that file I created. So that's fantastic. The lesson learned from this experiment is directory images are universal. They can come from a variety of sources. Don't even have to come from a container image. If you download the source code for a Linux release, like Alpine, which is a Linux release that you can find on GitHub, you download the source code, it's just a tarball. You unpack the tarball, it's just a bunch of files. There's no concept of container image. And yet, it will work because container runtimes can read file systems and understand that they are file systems if they're in a directory format. I have some slides to show that that's the case. If you wanted to do this, you should not do this. It's just kind of obnoxious. It's a proof of concept. You download the tarball, you unpack the tarball, you chrun, and it works fine. So the next topic will be container recipes. There's about 30 minutes left until the end of the course, and I would like to take a short break, and then I'll show you container recipes. Do I need a break? I guess I don't need a break. We had one break. It was only half an hour ago. Okay, I guess I'll just show you container recipes. Robert, thank you for attending the short course. I hope you have an excellent week. For those of us who have 30 more minutes, we will learn container recipes. So today we did some activities. We modified containers by hand. It's fun, it's educational, but it's a bad practice because now the information about what steps were taken is lost. So if you want to do it again, you have to recreate the steps. So to solve this problem, we write down the steps in a recipe. And every container runtime has its own format for how you write that recipe. So Docker uses a recipe file format, which we call Dockerfile. It's a plain text file, but what text goes in the file is Docker format. Charliecloud also supports Docker files. So if you tell Charliecloud, this is a recipe, and it's a Docker file, then Charliecloud can execute the recipe. Singularity uses a different format called a definition file. It's also plain text, but the words that go in it are specific to Singularity. The Docker file and the definition file are like one-to-one. They contain the same steps, just written in a different way. So this is the steps I wish to take. I wish to construct an Alma Linux image that has Python and a Python script. The Python script is hello.py. It will be in the image. Also, we need a Python interpreter. So these are the steps I would take if I was constructing Python and a script on the bare metal. I would execute yum. Yum is the Alma Linux command to install Python. I would create a file and I would execute chmod to make it an executable script. But we don't want to execute these commands one at a time. We want to make a recipe. And then we want to tell Charliecloud or Singularity to execute these commands in image builder mode so that we can repeatedly build the image without having to rewrite the steps. So if we express those installation steps in the language of Dockerfile, we need 4 lines. From explains the starting point of the recipe, which is an existing image. Run is execute this command inside a container pointing at that image. Copy means also add this file to the image. And then we have one more run command to execute one more inside the image. So run executes commands in a container inside the image, the same as our bash interpreter that we were doing before. Copy moves from outside to inside, and from looks in the local image repository. So Charliecloud has a local image repository, for example. So if we're going to do the Docker file method, we need to create the Docker file and the hello script, and we will be putting them on disk somewhere we can find them. So we already have a C tutorial. Since I'm going to be showing the Docker and I'm also going to be showing the definition, I want to keep them organized and separate from each other. So I'm creating a subdirectory. It's just for staying organized. It's not part of the recipe. And I'm actually going to do okay. June is asking a question. Do we always need a Linux OS for the base image? As a regular human with no superpowers, just typing on a keyboard, I expect you will always choose a base image. Usually, it will be an operating system or some commonly used bundle of software. For example, if you're working with GPUs, your base image will be the GPU software like CUDA. If you're using NVIDIA, you would download a base image that's operating system plus the CUDA toolkit. And that would be your base image. In theory, it is possible to construct an image from nothing, but you would have to put in literally every file and directory all the way down to like ls. If you want ls to be a thing you can do, you have to put it in. Nobody does that. The extreme Linux nerds don't even do that. That's just painful. So please don't do that. Henry has a question. Can we transform back into Docker format? Yes, you can. The reverse transformations are also possible. I don't have an example in this tutorial, but one way to do it is to upload your image to Docker Hub. When you upload your image to Docker Hub, it implicitly converts it into the Docker file format. So you don't have to worry about that. And the Charliecloud and Singularity runtimes can both do that. They can both do upload an image to Docker Hub. That's an example of a way to do that. I'm not saying you should do that. That's just at 3:38 p.m. at the end of a tutorial. That's what came off the top of my head. Do you want me to proceed with the recipe example? So in order to create these two files, you can create files on the command line, but it's tedious. I'm not going to do that. I'm going to create files using the portal. The portal has a file navigator. And the file navigator has a file editor. So I can create a new file called Docker file. And I can go 3 dots edit. And I can drop the contents of the Docker file in here. If you're on a Windows machine, do be careful about those Windows control characters. Sometimes you end up with carriage returns. Ever heard of carriage returns? They're annoying. So now if I'm on my command line, I can see that Docker file exists. And if I was on a Windows machine, I would execute DOS to Unix to get rid of those annoying Windows carriage returns. I also need hello.py. So I'll do new file, hello.py, 3 dots, edit, drop the code in. Save. And then get rid of the annoying carriage returns as well. So now I have Docker file and hello.py. Oh, and I wanted to have them be in a directory. It doesn't matter what you call it. It's not part of the recipe. I just wanted the files to be separated from the other files. And you can move files from here as well. You just check mark them and move them. But I'm tired and I'm almost out of time in the tutorial, so I'm just trying to keep it moving. So if we go to that location where those 2 files are, oh, I'm on the login. I'm on the compute node. I guess it's fine to be on the compute node. If we're using the Docker file, then we're going to build with Charliecloud. So I have to make sure Charliecloud is loaded. I don't remember. Yes, Charliecloud is loaded. And if you're on a compute node, then web proxy must also be loaded. So we want to chimage build T, which is short for tag, means how do you want to name the output image? So I could name it hello. And F is, this is the file that contains the recipe. And dot is the context, meaning if the recipe refers to other files, like hello.py, where can they be found? They can be found in the current directory, and dot is just that. So I am executing chimage build. First, because there wasn't, so first it's going to fetch from Docker Hub, because Charliecloud didn't have a copy yet, but now it does. And then in step 2, it's going to run installing Python. Lots of debug output for installing Python. Then it copies the hello py, then it makes it an executable. And now we have hello. Where is hello? Well, it's not here. It's going to be in the chimage storage. So if I execute chimage list, we'll see that Charliecloud now knows about Alma Linux and hello. So what does hello do? Well, I don't want to run files out of the local repository because that's a directory format. I would like a single file format. So I'm going to do chconvert hello to hello.sqfs. Oh, it's a little slower because this image is a little bigger. We put Python in there. Python is not small. This will take about 30 seconds. Anybody doing the recipe along with me? So now I have hello.sqfs. So I can chrun hello.sqfs, and I want to execute the hello script, which I put in there. And it works. So you'll notice that hello.py is not on the real file system. It's only present in the image. So chrun hello.py is necessary. Well, I guess there's a hello.py right here, but it's not executable. It only became executable during the recipe process. And another fun fact is we could compare the Python we installed. So chrun hello.sqfs, we installed Python in there. What version is it? Now, for this particular command, we need the extra dash dash because version is a Python argument, not a chrun argument. Dash dash is the Linux convention for the arguments after this one don't belong to the executables before this one. So everything to the left of dash dash belongs to chrun. Everything to the right of dash dash does not belong to chrun. So Python will be the executable that interprets dash dash version. Oops, it needs to be Python 3. Okay, so Python 3 says it's version 3.9. Well, this compute node also has Python 3, but it's not Python 3.9, it's Python 3.6. So that's how you can get a different version of Python on a compute node. You just have to put it in a container. So there's about 15 minutes left. In theory, there's enough time to do all of that over again, but with the Singularity definition file. Anybody here interested in the Singularity definition file as a live exercise? Or would you rather ask a different question? The result of this exercise will be the same. The difference is that Singularity definition files use this syntax. So instead of from, which looks very similar, we have to specify the format. So Charliecloud, if you put an image in the from, but don't specify its format, it will use the default format, which is the Docker format. Singularity does not allow you to have a default file format, so even if you're fetching from Docker Hub, you still have to specify the file format of the source. So Bootstrap says, we're coming from an image that's in the Docker format. From is, which image is it? It's this one. Now, the definition file, instead of labeling each line by what kind of command it is, we group the commands into sections by what kind of command they are. So the files section means for each line in this section, copy this file from outside to inside. And the post section means after you put the files in, run these commands in the container. They're the same commands, but instead of running them one at a time, we just do all of them in a post section. Post means you do it after you, after fetching the base image. If you had a pre section, it would be, here's some things to do before you fetch the base image. I don't know if there's really much of a point to that. It's a mystery to me. Henry asks a question. In which cases would you recommend to use Singularity or Charliecloud for image building? If you're making a recipe from scratch, then you just use your favorite. But if somebody gives you a recipe, then it's more convenient to use a runtime that can read that recipe. So the majority of recipe files I see on the internet are Docker files. Therefore, when I'm building from a recipe that I got from the internet, I usually will use Charliecloud because then I don't have to rewrite the recipe. Charliecloud already can read a Docker file recipe. If somebody gave me a definition file, I would use Singularity to build it. If somebody gives me a recipe that's just chicken scratch, then I will convert it to one of these two formats based on how I'm feeling at that moment. Charliecloud and Singularity have basically all the same capabilities in terms of what kinds of images they can build. So I'm not aware of a specific reason why you should not choose one of them. It is rarely the case that neither of them can build the image. Some recipes include commands that are specific to the Docker runtime, not the Docker file format, but the Docker runtime interpreting the Docker file format. If the recipe includes Docker specific actions, then only the Docker runtime can take those actions. In that case, you'll need some help to build the image. Charliecloud and Singularity can't do it. But the example I'm showing you here doesn't have any Docker specific actions. These are all just normal Linux actions. Move a file, execute a command. Any runtime can execute those actions. Thank you for your questions. I'm going to skip showing this exercise because you get the same result. You just use Singularity build with the proper argument, Singularity exec with the proper argument, same result. You can do this exercise if you want. I'm going to show my acknowledgement slide. This work was supported by the National Science Foundation. The main grant, of course, being the ACES grant that paid for the cluster that we used to do our exercises. Also, the Sweeter grant, which paid for some of my time developing the exercises. I would like to thank the staff and students who work with me at HPRC. I would not be able to run a successful tutorial by myself without people monitoring Zoom, helping with those weird problems, making sure that the announcements go out on time. And finally, I would like to thank ACES because they rewarded me with a CSAP grant after I created this tutorial, which I used the funds to travel to the PERC conference. So that was nice. Thank you. We have a short course survey. If you're viewing the screen, you can use the QR code. Otherwise, you might as well click on the link. I'm dropping the link in the Zoom chat. The QR code and the link are the same thing. They both take you to a Google form, which is our short course survey. We would like your feedback about what you learned, what you would like to learn, so that we can improve our short courses for the future.